Here's the notes for 4.1.4. It's the idea of factoring completely. So we're really going to be talking about looking at GCFs today specifically. So carrying on with where we left off with 4.1.3. All right, so when we're talking about factoring quadratics specifically, normally the first thing that I do is really look for a GCF. If there is a number or a variable or some combination thereof that can be pulled out of all of the terms, so divided out, so out in front, you're definitely going to want to do that. It makes your factoring a little bit easier from then on because typically it's going to shrink the numbers into something that's a bit more manageable, and then it'll get rid of what look like extra variables that we wouldn't necessarily call extra, but still. Then from here, it's about determining how many terms you have. So you want to figure out, typically, we're talking about 2 or 3 terms. So if we take a look off to the left-hand side, the 2 terms. When we're talking about 2 terms or binomial factoring, binomial, to the bi in front is 2, and it's the polynomial, so binomial part. As the difference of squares, we have this nice, pretty slick pattern here, which we're going to go through and take a look at today. And we're going to use that formula. So it's going to be a squared minus b squared is equal to a minus b and a plus b. But then the other thing that it could be is maybe you're talking about 3 terms or a trinomial. Well, these are the ones that we've been doing the most. And this is you take out the boxes and you take out the diamonds, or you can take a look at how we did it in class previously where we did a little bit of guess and check, or you could do the grouping portion. Any of those are viable techniques. So with this one, this is going to be the diamond and or rectangle. All right, moving on. So the majority of what we're going to be looking at today, actually I think all of it, is going to come directly from those notes that you guys have and was given to you on the day of the test. So it was when you had 4.1.1. The first thing that we're going to do really is look for greatest common factor. So you're looking for the thing or things that you could take out of all of the terms. So I'm going to go through and take a look at these, but I'm going to go in pieces. First thing I'm going to do is take a look at the numbers. So I'm going to take a look at the 6, the 12, and the 18. Okay, the biggest number that I know goes into all 3 of those is going to be 6. So the 6 is the numeric portion of the GCF. All right, let's take a look at the variables. So I've got an x squared here because I'm just looking at the x's. I've got an x here, but then if you take a look at the last piece, there's no x. And you can't take more than what somebody has. So we're not going to take out an x of any kind because not everybody has one. And we'll take a look here. We've got a y. Okay, this one has a y also. And the last one has a y squared. All right, they all have a y that they can give up. Again, you can't take more than what everybody has. So I'm going to take out a single y. Although the last term had a y squared in it, you can't take 2 away from the other ones. Okay, so let's go ahead and put that GCF of 6y out in front. And then what we're going to do is we're going to divide. So I'm going to take a look at this first part here. And we're just going to kind of dissect it a little bit. So if I take a look at the 6, well, I know that my GCF of 6 divides into that 6 once. Okay, then I'll take a look at the x squared. So I'm just going to go piece by piece. I didn't take any x's out, so the x squared is still inside. And then I've got this y. Well, I took out the GCF of y, and so that means this y is completely handled. So I think the only thing we have from the first term that's left over is 1x squared. Now, if you were to take those 2 things, the 6y and the 1x squared, you'll get back what you started with in the first place. All right, let's move on. So now we're going to take a look at the next one. We've got a 12 here. Okay, GCF was 6. 6 goes into 12 2 times. Okay, looks like there's an x. Well, we didn't take any x's out, so this x still remains. And then we have the y, but there was a GCF of y, so this y's already been taken out. So that's going to give us a 2x. Okay, let's move on to the next one. And this time I am going to pay attention to the sign. It's not that I ignored it previously, but it was a positive sign, so it knew it wasn't going to make any bit of a difference. Okay, so my GCF of 6, all right, in order to get a negative 18, I'm going to need a negative 3. And then I'm going to take a look at the y squared here. Okay, the GCF had a single y in it. That means that there is another y left over. Again, you can always check to see if your answer makes sense based off of if you were to multiply this all out, you would get back what you started with in the original question. Okay, take a look at number 3. Or, excuse me, the binomial factoring here. All right, so GCF, well, the numbers, that's all divisible by 3, and there are no variables that I could take out. So I'm going to take that 3 out, and I'm going to divide. So 3 goes into 75 25 times, and then I still have the x squared, and then 3 goes into negative 3, negative 1. All right, now we're not quite done. You want to take a look inside the parentheses, and you'll notice that I can square root the first term. I can square root the second term, and it's a minus between them. Okay, so this is going to be that difference of squares that I referred to on the previous slide. So we're going to automatically go to 2 sets of parentheses. All right, I'm going to square root 5x squared. Well, square root of 25 is 5. Square root of x squared is x. Those are going to go in first into each set of parentheses. Okay, I'm going to take a look at the second term. I'm going to square root 1. Well, the square root of 1 is 1. Then, in order to satisfy that negative sign, the only way this is going to work is if the signs are opposite each other. So one of these is going to be a negative, the other one is going to be a positive. Last but not least, do not forget to bring your GCF with you. So we're going to bring that 3 down from the previous one. And then I believe we are done. So not only was there a GCF, but we also have this difference of squares. Okay, trinomial factoring. Now we're back to the stuff that we've been doing for quite a while, or for the last couple of sections. So we're going to take out the GCF. Well, those are all divisible by 5. And then I can't take any variables out because, again, everybody has to be able to give up the same thing. All right, so let's take that 5 out, and we're going to divide everybody by 5. Okay. Now look inside the parentheses, and we're going to try to keep factoring. So that is a trinomial, which means I am thinking we're going to use the boxes and the diamonds. So take out the box. Let's put everything where it goes. And it's just the stuff that's orange highlighted. All right. Let's take out the diamond. Multiply those 2 inside the boxes. So multiply along the diagonal. That's going to go in the top. Then go back to the orange highlight. And the middle term is what's going to go in the bottom. All right. So we need to multiply and add to make this happen. I think these are 4 x's. All right. So take those guys, and we're going to put them into the 2 empty boxes. And then we're going to factor. So if I take a look here, I know that I can take an x out of those. And then if I look at the row, I think I can take an x out of those. And once we have one of them, so one of the pieces of the outside, we should be able to find the rest of the outside as well. It's kind of like this big puzzle just kind of unfurls. All right, so our answer. I'm going to take a look at this thing, and it looks like I have an x plus 4 base and an x plus 4 height. Bring the GCF of 5 with me, put that in the front. Now this can be rewritten because the parentheses are the same. So this is going to be x plus 4 squared. Now this is actually telling us something pretty interesting. So the orange stuff back that I highlighted, these guys are equivalent to each other. But whenever you have like parentheses squared, like this situation, what we know is that this was originally, it's called a perfect square trinomial. I think we have a couple more of those coming up as well. So just to give you a little bit of a heads up. And then my answer here is going to be the 5 quantity x plus 4 squared. Okay, at this point now, we really are just doing some practice of factoring. So why don't you, because 1 is just like stuff we've already done, why don't you pause the video and see if you can factor number 1 and then come back and check your answer. Okay, so there's my answer for question 1. Fairly straightforward. Okay, question 2 is a tiny bit more complicated. Question 2, I think there's a GCF, so let's take that out first. So I've got an 8, an 8, and a 30. I think I could take a 2 out of there, so I'll take out a 2. And then not the x's, but it does look like every single one of them could give up a y. So that's my GCF. And I'm going to go ahead and divide everybody by that. So taking a look at my first term, I have an 8 that divided by 2 is 4. X squared, none of them were taken out. Y, but the y was taken out. Okay, let's keep going. Negative 8 divided by 2 is going to be negative 4. The x is still inside, and the y was taken out. Okay, 2 goes into negative 30, negative 15 times, and the y was taken out. All right, now I'm going to look inside the parentheses. I need to factor that. So now we're kind of back to what we'd been doing previously. So why don't you see if you can, and it is a trinomial, so you're going to use your boxes and diamonds or whatever method you choose. So why don't you see if you can factor the inside and come back and check your work. Okay, so I've got the boxes and the diamond filled in. All right, so let's take the base of 2x plus 3, the height of 2x minus 5. So that was the orange stuff that I factored. But don't forget the GCF. I'm going to put that 2y back out in front. So make sure that you keep that with you. Let's color code this. So way back up at the top, we took out a GCF of 2y. Make sure that 2y goes with you in the final answer. Okay, I think we have some more practice problems to go. All right, so same idea here. My recommendation to you is to pause it, do the first question, so number 3. Then unpause it, check your work. So I'm going to do them in phases. So I'm going to pause right now, do question number 3. I recommend you do the same, and then come back and check your answer. Okay, so I pulled out my GCF of 3, and then I attempted to set up the boxes and the diamonds. But this one can't be done. I can't get to negative 10x squared multiplying and then simultaneously get to negative 5x adding. So I'm not going to say that it's prime. Prime means that you can't do anything, but I could. I took out the 3. So final answer here is going to be, well, exactly what you got when you took the GCF out. So it's going to be 3 on the outside, 2x squared minus 5x minus 5. Sometimes the only thing you can do, sorry about that. Sometimes the only thing you can do is to just take out the GCF. All right, so pause, see if you can do 4, then come back and check. Okay, so I took out my GCF of 3, and then I ended up with the 6x squared plus 11x minus 7, which I then put inside the boxes, and I was able to factor. So the base of this is the 2x minus 1. The height of it was 3x plus 7. And then that green replaces the original. And then if you take a look back, we did have a GCF of 3. Make sure that that goes along with us as well. So there's our GCF of 3 that we took out originally. So I think that's our answer for this one. All right, see if you can try 5. Okay, so this one's interesting because we have a GCF of 2y, which I took out, but then if you look inside the parentheses, we have a binomial that we can do square roots of. So if I square rooted the 4x squared, that's where my 2x's came from. Square root the 49, that's where my 7's came from. And then I do have the minus sign. Gotta have the minus sign for this to work. So then there's my factorization for this problem. And then it looks like we just have this one more question. So why don't you see if you can do this last one. Okay, and then question number 6, the numbers are fairly large, so maybe there'd be a GCF, but there actually isn't. So then I went through, did the multiplication, set up the diamond and the rectangle, and then I ended up with 4x minus 3 times 4x minus 3. However, that means because they're identical that I could rewrite them as quantity squared. So remember, because of the way this answer looks, the 4x minus 3 squared, I know that this was a perfect square trinomial.